Okay, this is 7.4, and I'm going to go skip down to number 8 and then come back to number 5, just because it's kind of a different thing. We've already done a couple examples in class, but we were waiting on the iPad to clear up so we could record an example for people who are absent. Now, what I've already explained, and we've already talked about in class, for those of you listening on the video, is that I could get a common denominator, and that's one way we can work this, but we tend to learn that in Algebra 2. So what I'm going to do here is just clear out the denominator, okay? So there's a couple of ways to solve these. One way is to clear your denominators out. So you look and say, okay, I've got a 2a, and I got a 6 and a 3a. If I want everything to cancel out, it would be the same thing as finding a common denominator. What would be the biggest number here? If I multiply through, if I look at my denominators, if I multiply through by 2, that's not going to clear out everything, is it? 3 is not going to clear out everything, but isn't 2 times 3 6? Yeah. So if I multiplied everything by 6, wouldn't that clear all the numbers out? Okay, so I know one thing I want to do is multiply both sides by 6. This is one method of solving this. It's just called clearing the fractions. And then I got some a's in the denominator, so I'm going to also need to multiply through to get the a's to cancel out. Because what my goal is to get all my fractions, all my denominators and my fractions to cancel out so that I don't have fractions anymore. When you learn how to do this with a common denominator, this same 6a will be our common denominator. So we could solve this by doing something a little differently here. So now this 6a has to get multiplied by everything in the whole equation, so I've got to remember to distribute it. So what I'm going to do is go ahead and rewrite 6a times 3 over 2a, and I'm going to put 6a times 5 over 6. I'm just distributing here. I'm just going to just write it out so I can cancel out and make it a little easier. And then on the other side, I know I've got to multiply 2 over 3a times 6a. So let's go ahead and simplify it and get that, at least that half done. What's going to cancel out on your right-hand side? The a's, good, they're gone. And then 3 goes into 3 one time, and it goes into 6 twice, doesn't it? So now we just have, the denominator's all gone, which is really what we wanted to have happen. And 2 times 2 is just 4, isn't it? So I simplified the right-hand side just because, I could go ahead and do it. And now I'm going to go back and simplify the left-hand side. I just wanted to write down exactly what we were doing when we distributed. Okay, so looking at the first term, don't the a's cancel out, right? And then you got a 2 in the denominator. 2 goes into 2 one time, and it goes into 6 3 times, right? Now, if it bothers you that I'm canceling stuff out from a fraction and a whole number, remember, you can always write 6a over 1, and maybe your brain will kick in a little bit better. Sometimes just writing things in a way that your brain likes to see it can help you make less mistakes and feel a little more comfortable in what we're doing here. The denominator's all canceled out, and don't I just have a 3 times 3 left? So that's what, 9? What about on that second term? What's going to cancel out? The 6's, yeah. So the 6's cancel out. 6 goes into 6 once. 6 goes into 6 once. Denominator's gone, because when you got 1 on a denominator, you can ignore it, right? So I have a 5 and an a left. Okay, so I'm going to write that down. And now, this is the problem that's a little easier to solve. We had a whole bunch of fractions, and look how easy that made it. It got rid of every single one of them, didn't it? Now, the reason in Algebra 2 we use a common denominator is that eventually you're going to go graph stuff like this, but it'll be written in terms of x's and y's and stuff. And when you graph it, those things that are canceling out actually make a big difference when you graph an equation. They create places in your graph where you don't have a value, because they're in a denominator you can't have a 0. So that's something you're going to learn in Algebra 2, but just going to mention it here. Now all I got to do, though, if we're just solving these, let's get a by itself. What I could subtract 9 from both sides. 9 minus 9 is 0. I would have a negative. Remember, 0 minus 5a is just negative 5a, isn't it? You just write down the minus 5a and change it from a subtraction sign to a negative sign there. What's 4 minus 9?
Negative 5.
Good. Negative 5. Bless you. If I want to get a by itself, what am I going to do now? Yeah, not add 5. Some people would say, oh, I add 5. No. That's attached. It's smushed together. It's multiplication, isn't it? So we're going to divide both sides by negative 5. And so the negative 5's cancel out and leave me with a equal, and negative 5 over negative 5, you can't read that because it ran off the screen, Anything divided by itself is just 1, isn't it? Anybody know what to do on number 5? Bless you. Do you notice that on one side you have a fraction, on the other side you have a fraction? When you have a fraction equal a fraction, do y'all remember that that's called a proportion? I mean, I could do what I've been doing on these other problems. I could multiply both sides times 5 and n minus 2. But if you remember, the easier way to do it is if you have a fraction equal a fraction, that's a proportion. And remember, we've talked about those we talked about them with percents and all kinds of places, and they're a big deal in math, and this is an easy way to solve those. If you remember how to solve proportions, you cross multiply. You say, you multiply one diagonal, 5 times n is 5n, and then you got to write your equal sign. You don't just cram it all together. And then you multiply the other diagonal. You multiply each diagonal and you set them equal to each other. So this would be 6 times n minus 2, and I better put a parenthesis there because aren't I going to have to distribute? Some people can do that in their head and not mess up. So if you can say 6 times n minus 2 is 6n minus 12, you could write it down there. You don't have to write this 6 times n minus 2 unless you need to. I always write it because I'm always afraid that I'm just going to mess up somehow. I'm overly cautious when I do things just to make sure I don't make mistakes because I know me well enough. So it's 6 times n minus 2 in parentheses because there's more than one term, so I have to distribute. 6 times n is 6n, and 6 times minus 2, or negative 2, would be negative 12, or I could say, write down my subtraction sign, and 6 times 2 is 12. A couple of ways people think about that. Now, there's a couple of ways to solve it at this point. Some people don't like having negative numbers, so they would move the 5n over with the 6n and move the 12 to the other side. I'm going to go ahead and do it with negatives just to show you that it's not a big deal. Usually, well, maybe not. Usually don't we say we look at the side that has the bigger amount of variables and we move everything to that side? Let's go ahead and do it that way. You don't have to do it this way. This is actually an extra step, but it's okay. I got 6 n's over here. I got 5 n's over here. Let's move the n's together. When I subtract the 5n from both sides, I can't just go, and they canceled out, and leave that empty, because what's going to happen is I'm not going to have anything on my left-hand side, am I? How do you solve something if you have an equal sign and nothing written on the other side? You don't. You said it, Luke. 5n minus 5n is actually 0, isn't it? 0 is a number, and if there's nothing else left, you have to write it. It is 0. That's what it did add up to. And on the other side, 6n minus 5n is just n, isn't it? 1n, which we'll write as n. n minus 12 is equal to 0. If I want to get the n by itself, then all I have to do is just scoot that 12 over to the other side by doing the opposite. It was a minus 12, so we need a plus 12. Oh, there's our answer. It's a word problems too to look at. Number 11, I want you to look at what happens. We could actually solve this problem with logic if we look at it. What do you know about 1? Isn't anything over itself 1? If they're telling you the left-hand side is equal to 1, and you look at the right-hand side, there's no way you could have an x and add 5 and then take that same x and subtract 2 and have it equal to 1. So logically, you could look at this and realize there's not going to be a solution. But let's say you don't think about that, because sometimes we don't think about that. This is a good problem to look at because this happens a whole lot in some things we're going to do later this year. You're going to get these kind of answers and you need to know how to interpret them. So I'm going to pretend that I don't know that, okay? I'm going to say, oh, here's a problem, let's just solve it. The right-hand side was a fraction, so what I did, since it's just a single fraction, on the other side I had a whole number, so I'm just going to stick it over 1, because didn't I just create a proportion to solve? It's something that you do so much that when I see that, do y'all see how I just automatically did it and I didn't even think to explain to you why I did it at first? You need to train your eye to get that way. When you see a single fraction on one side and a number on the other, make the other one into a fraction, because now you can cross multiply. It's going to save you a lot of time in a lot of places in math. So if I cross multiply, since it's a proportion, that's how I'm going to solve it. 1 times x plus 5, 1 times anything is just itself, right? And let me cross multiply, do the other diagonal. 1 times x minus 2 is just x minus 2. Okay, let's look at what's going to happen to our answer. Are our x's on the same side? Oh, they got one on each side, right? Oh, hi, Adam. Hi. Good to see you. So the x's are on different sides of the equation. Which side should I move them to? They're the same on both sides. That's weird, huh? Hi, I'm kind of stealing your seat, but you'll just sit there. Thanks. Well, it really doesn't matter. Let me go ahead and do that. Okay, I'll do that. I'll move this one over there just because I got to make a decision. If I subtract x to move it from both sides, look what happens. The x's cancel out, and I get 0 plus 5 is 5. And on the other side, x minus x adds up to 0, and 0 minus 2 is just negative 2. A lot of times we just drop that minus 2 down and call it a negative 2. Can 5 equal negative 2? No, this is never, ever true. Never, ever, ever true. This is nonsense, as a matter of fact, isn't it? So we go, there are no solutions. When you get something like this in any math situation, if all the variables cancel out and you get something nonsensical like this, you just go, oh, there's no solution. And that happens sometimes.